Hello everyone, this is Bradley. So today this is a tutorial, or actually more of a voiced recording of this kind of a recursive subdivision animation. I'm not going to cover all the topics. I'm only going to discuss the major parts so that how you can actually replicate this kind of architecture. And in the past, I've done in similar kind of concepts in animation nodes using Houdini's approach. But due to many limitations in geometry nodes, we're going to take another approach, which is essentially inspired by BBN19 on Twitter. So let's start. So here we're in Blender, and the first thing I'm going to do is to make a plane. And within this plane, we are going to do several things. So let's firstly go to the top view and goes to the item. Because this plane is a 2-2 dimension, which I do not need. So let's change this dimension into 1-1. And another thing that you realize, we changed the dimension, but we didn't change the scale. So let's apply Control A and apply the scale. So that scale is 1-1. Otherwise, the value is still not correct. Next thing I'm going to go to edit mode, and I think I'm going to shift by 1-1. Oh no, 0.5. Yes, now this is correct. Okay. This is because I want to make sure the values I'm using is 0, 0, and 1, 1. Once we're more comfortable with the whole setup, then we can make that back to like a 2, 2 without offset or something like that. It does not really matter. But as a starter, I think this is the best to go. So let's go to nodings. I'm going to duplicate this object, and let's rename the other as a visual. And the first plane is GM, because we're going to add a geometry nodes modifier onto that. The second object, we are going to go to viewports display and change the color into red, so that we can see that better if we change the viewport shading to object mode. Okay, so goes to the top view, and our original plane is blocking our view, which is okay, because soon we won't see this plane at all, because you have to cut this line. Okay, next thing I'm going to do is take a mesh line. This is actually already my second time of recording, because I did a recording yesterday night when I was very tired, and it didn't run well. One side is because this is kind of very difficult. On the other hand, it's sometimes when you're tired, you just don't know what you're doing. Okay, so now this is fine. Currently, we have this radius, so it shows the points, and then we are going to redefine these points with this position like a set point file. Okay, so this is good. This is good. Another thing that I'm going to do next is to set up points somewhere between here and there. Okay, so this value must be smaller than 1, as we know. So let's name this as a value x. So if I make a x here, then the other part is 1 minus x. So this is a little bit kind of simple math. How we're going to do is basically take a random value, combine x, y, z, plug these x values, take the positions, geometry into mesh, and we can see it now. So this random value being generated is about 0. Yeah, it says ID. Okay, fine. Something like 0.9, I guess. And let's join geometry. Okay. Then if I'm having this kind of distance, then for our grid that being instanced, instanced points, the scale will be x as well. So here we're going to plug this random value to the place, and to the radius, because radius can help deal with the scale of our object later. So we can plug that to the scale after combining x, y, z, because we're only going to affect the x, not the other part. Okay, so here I think we can put our original plane into the instance. Okay, it's not. So let's generate our own plane. So let's take a grid, and I'm going to offset that by 0.5, 0.5. So plug that in, and let's, I think, let's firstly see our plane. Plane is here, and let's move that to 0.5. And then another 0.5. No, actually this will be fine. Okay, then let's geometries into instances. Okay, so now this is okay. This is okay, but we see did we actually generate a good geometry? Yes, we have two planes which is matching each other, and you can definitely change the seed, and it starts not working. Because if we change the seed, you can see we finished one part, which is okay, but the other part is not filling the area because we didn't not use the 1 minus x. So let's do that. Take a math and subtract 1 minus our x, and then plug into the radius. And this is actually, this runs pretty well. So if we change the seed, it always match. So this is kind of a basic cutting of a single plane. Here, just to remind you that this random value is not very good for animation because the change in the seed is kind of abrupt change. However, what you can do is you can use any kind of texture, and frequently I think noise texture would just be fine. And you can use the factor to replace the value, and you can either animate this W as a way of animation, or you can actually combine X, Y, Z and dealing with the vector to deal with the animation. Either way you like. For the moment, I will just still use this random value for demonstration purposes, because later we're going to talk about the concept of ID or iteration or index. And before we head into the further steps to really cut this multiple times, which is really kind of recursion, I would like to briefly talk about the principle of this first cutting. So it feels like we are cutting a square into two pieces, but the reality is that we are just instancing two grids with different scale. So this is very important as we are doing the next step, because you need to realize that whatever we are having is a grid, so that we can actually rotate the grid to have a different axis of cutting. And you will see more just a few minutes later. So let's move on to the next step, that we're going to do this kind of recursive cutting. And let's change the organization a little bit. Okay. Talking about the because Blender does not provide any function of loop yet, so we have to do that a little bit manually. I will discuss the similar kind of things in my previous tutorial, in which we're talking about that expanding helix, and I've shown you the presets. And the menu means you have to duplicate this kind of group nodes of the same function manually, and then you have to connect each of sockets. The good part is that you can select all this kind of node and keep hitting F, so that you connect all the sockets to do the function. So it's not as painful as I would imagine, but it's still not 100% procedural. Especially, but on the other hand, I don't think you are going to really do the recursion for thousands of times, because technically speaking, the amount of cut will increase exponentially. So probably 5 or 6 cuts are the maximum that it will go, which is not too difficult to just shift the D and duplicate. Okay, so this is kind of idea. So let's move on to do the recursion. For the time being, I'm going to delete this noise texture just to clean up the trees a little bit more. And then I'm because I need a group node, so I'm just select all this node and hit Control G, so that putting them into a new group node. Within these new group nodes, firstly, I'm going to create a geometry, because we're going to input the geometry from the last loop. And next thing I'm going to create is I'm going to plug this ID into the place. I'm going to expose this value, but we are not going to really use that. There are several important things. So this the entire concept of looping is that you just put the result of your last calculation and to the next time and run the same operation and keep going. So this is the idea of loop. In this particular case, it's very important to know whether this is the first node that you use, or the second node you use, third node you use, fourth node you use, fifth node you use. So you have to keep an ID or whatever things you call, but you need to have this kind of value to indicate. In this case, we start from 0, and for our first node, its value will be 1. And for the second node, this value will be 2. This also causes a different seed within the random value at some point, but this part is not very significant. I will show you why. But firstly, let's just output this value to the group output. And then I'm going to change the name into ID. This is just for kind of recognition purposes. And the rest, I think this is all done. There's only one thing that I want to mention is for our first loop, we definitely would like to make sure we're cutting using the grid. And for the second loop, we're going to use this product to instance that inside this part. Okay, so this is kind of idea of this whole thing, which means we need to make a switch to distinguish if this is the first loop, float compare. If this is our first loop, which means the index equals to 1, then it uses the grids. Otherwise, it will use the geometry from the loop input. And then we replace this entire linkage. And immediately, we should be able to see the effect. Let's name that as a unit. Or you can name whatever you want, it does not really matter. And then duplicate this for one time. And immediately you can see there is multiple cuttings, more cutting than we see. Originally we have 1 cut, now we have 3 cuts. And we can keep doing this so that we have more and more cuts. We will deal with kind of randomization a little bit later, but now the first important thing is you realize, hey, there's actually a bug. Every time we are trying to increase the amount of cut, there is a movement towards the y-axis. Okay, so here we also need to do another switch. This kind of movement is mostly caused by this 0.5 increment. So here what we do is we're going to change that to float and using the same comparison. So let's move this a little bit left. If this is the first loop, then we're going to use this 0.5. Otherwise, we no longer need to use this 0.5. So now everything has been recovered. Talking about the variances, the major issue here is that we're actually doing instancing instead of creating new geometry. That's why over the time you can actually see there is a kind of clearly repetitive patterns from time to time. And this is kind of unavoidable. I think this is also why Houdini is not using this method. Rather, they are trying to access point A and point B every time and to generate a new X with their loop function. This is also how animation nodes really approach this function. But in geometry nodes currently, we cannot really do this, especially if we're using this kind of methods. However, we can still cheat to make it looks like we're generating random value every time. And this is what we're trying to discuss later. The method that we will use to cheat is the rotation. Previously, I already mentioned the importance of having the square as our starting in geometry. Because no matter how you rotate a square on a plane axis, it's still a square. So you do not notice the rotation. In this case, if I rotate this square, then the cutting will be this place. Rotating another 90 degree will be that place. Rotating another 90 degree will be that place. So it feels like the rotation gives you an illusion that it changes the direction of cutting. It also changes the magnitude of cutting. So this is an illusion but it does work. To really implement this, so let's go to unit. I'm firstly going to create a full state of these rotations using the point instance. And so let's take the point instance. And I'm going to instance that 4 times. The method I'm going to use is just to take the 4 mesh lines and the geometry into points. And because we already have an offset at 1, so if we change the view, then this is what it looks like. Next thing, if I directly rotate this entire whole thing, something will change. The actual reason is that we're not only rotating our instances from the previous inputs, but also our grid, because we do not want to rotate these grids as we are working. So here what we can do is that we can tell the, so firstly we're going to use the rotate instances, and I'm going to disable this local space, and then I'm going to tell a switch. If this is the first loop in which we're using the grid as the instances, then we're not going to rotate. So this is the vector that we have. However, if this is our second time of this kind of rotation, second time of instances, then we're going to rotate. And then I'm going to change the pivot to 0.5. So this is the idea, and if we try to instance it, then we can see the rotation that occurs. And let's rotate about 90 degrees. Actually, the rotation is not. So this is pi divided by 2. So this is 90 degrees. So the input you give is essentially in radius instead of the degree. So you need to do a little bit of conversion. So here I'm going to take a float range, and every time I'm going to rotate by pi divided by 2, which is still about 1.5. Okay, and then I'm going to combine x, y, z. Hit this, take the vector. So now I have a lot of instances being generated at this moment. It's fine. This is acceptable. More important thing is that I'm going to pick instances, and this is what I'm getting from the top view. And it does not really work if we go to plane view, because we mesh line have and cause this kind of offset. So just to recover that, and this is what we get. So if we repeat the same process and keep continuing that, then you can see it just becomes like this. Okay. And because ID changes, instead of this float range, what we can also do is just to use the random value. And because previously our ID will change every time for the loop, so we can just plug this ID and just plug whatever values, maybe 1 million or 1,000, it does not really matter. But what we need to do is to snap that to the pi, half of pi. So use the snap function. Where is the snap? Yes, snap, and pi divided by 2, and plug that to z, so that every time I get a different rotation, supposedly, and this ID needs to add with index. Okay, so that you have different rotations. So this is probably the last step, that instead of using the random value, we're really going to use the noise texture at this step, so that we can start to animate everything instead of using the random value. And basically we can plug the ID directly into vector. We can use the 4D instead, so that we can actually start to animate it. So basically this is the point. you can realize the difference between this random value and the noise texture. This is, I think, because this random value is more likely to generate this kind of value at the extreme. This is not really a kind of equal probability. There is no fairness within this node. That's why sometimes it gives kind of a feeling which is very weird. But the noise texture is more kind of soft. You can also try to use other texture, maybe wave texture, magic texture, Voronoi texture. They probably will generate very nice and interesting results. Depends on what you actually deal with. Do we actually have white noise? White noise is also an option. The only issue is probably you can still animate that with the W actually. So if we change the white noise and then we animate this W, this is probably too abrupt. So probably no. Still, either you use noise or other functions, which is probably more proposable, in my opinion. Okay. As I previously mentioned, that you do not necessarily only to animate by using W, you can also use the vector. There are even other things that you can potentially do is to use the float curve so that you can change the number to something more kind of extreme. For example, this and that. So that's, yeah, sometimes it's just to play around with all these kind of settings. I do not know what you would like to do, but I think there are tons of possibility. I don't want to really just stop here because I want to add some more kind of interesting features. So here, let's do several things. Let's go outside the geometry node trees. And after this entire node tree, because we're only having actually 2 instances, so I'm going to realize the entire whole thing. Because this is a step we realize the whole things, and then we realize because this setup is being so perfect, so the plane is really tightly attaching to each other, so we do not really see any gap between them. This is pretty very interesting. So here I'm just going to make a little bit of gaps in between. Here what I'm going to do is to set a position. This is basically the polygon transition that you can do. So attribute capture to the face and take the vector positions and mix RGB. I think I will discuss this kind of concept in more details in the future, but at this moment you can just follow what I'm doing. So basically what you do is you get a kind of the center points or the polygon center, and then you mix the vertices towards the polygon center. It feels like kind of shrinkage, but just a little bit gap should be enough. Another thing is we do not have the extrude node in 3.0, so you either wait for 3.1 to do the extrusion using the similar method that we're using the capture attributes at the face domain, or the method that you can potentially cheat is I'm going to take a vector mask and then I'm going to combine XYZ and take the random value. This random value also should have a random index based on what we're having. So let's take the integer, or actually not the integer, index. Plug this index to ID. If we do not do that and then we directly do this Z, everything just has been crushed so badly. But if we plug this face ID into the place, then different face should have been elevated differently. We do see some issue with this setup. This is probably because of the fact that when we create this grid, there's face count is not good. Next, we just extrude it with the solidify modifier, and I'm going to just increase the amount to infinite, and then finally add a new geometry node trees after the solidify modifier. Let's rename that as clamp. So here what we can do is just to simple mask, set the position, a position separate XYZ, combine XYZ, and use a math node to tell that there's no number on the z-axis should be lower than 0, and finally plug this vector into. So now we have clamped it. We can definitely animate this more interesting by using Falloff to determine this kind of extruding amount. So for example, in this case, we can use the proximity Falloff and take a controller and take a mass, take a multiply, and using this custom positions, which is for the face origin, as a way to evaluate. Finally, let's just scale down these empties, and then you can actually animate this whole thing. And it's also possible that you have a very tiny controller, and then you expand it up, just increase its values, then everything has been grow like a city or something like that. You probably would like to subdivide this square a little bit more so that it becomes more interesting, but this is kind of idea. Other than working with the Falloff, there are many more things that you can do, as I've mentioned in my animation nodes tutorial. Basically, so now whatever we have here is basically like a plane, and if we ignore all these kind of parts of extrusion, what we can also do is, first let's transform this back to negative 0.5. So we have the origin, and then another transform, so everything set to 0, and rotate this 90 degree. Actually probably the other way around. And let's turn away this extrusion. So rotate 90 degree, and then we can use the simple deform modifier. We can bend on the axis so that we can make a cylinder shape, 360 degree. We can even turn that into a sphere. Just to know that you always need a lot more subdivision surfaces, and then also the ratios may be important. There are really lots of things that you can potentially do. It's just something you have to try by yourself. So that you can also form a kind of a sphere if you want, something like that. So I would say this is it. The rest you can try by yourself. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.